So we're gonna keep this short today. This is set to 30 minutes, out of which we will spend 10 minutes on the recap, 5 minutes on recap. Actually, let's let that time. 10 minutes on questions and 10 minutes looking things up, looking the concepts. Okay, so the first thing would be, let me just run through the process. So the social media app, Twitter was the question. I listed out the topics that came to mind of how Twitter would function. I did not do direct messages towards the end, and then I listed out. I made assumptions on how many users would be, how many active users we'd have, how many total users we'd have, and based on that I made storage estimates. And I moved on to the daily estimates for user details, tweets, and comments. So that's a bunch of math, and so I also had a couple of assumptions there, and these sizes were based on actual requirements of the number of users and the number of tweets that we could have and the number of comments for those tweets. There are a couple of questions which we will get to, and move to the design. I have the user interface which talks to the load balancer, and I have different services for user management, auth. So the idea is that the user management service deals with login, sign up, just mostly that. So what it tries to do is, and when a user is trying to sign up and they want a username, right? So what we do is, instead of it hitting the database every single time to check if a username is available, what we will do is have only a cache of only the usernames, no other details, just the usernames. So the user management service can look up the username in the cache, and if it's in the cache, it'll immediately return the response and say, hey, it's already there. So the user tries a different username, and if it's not in the cache, it checks in the database and says, okay, is it in the database? So if it is not in the database, then you know that the user can use that username. If it is in the database, then it updates the cache, goes back, and that's that. So that's the idea of the user cache and the user management DB. Now, what the auth service does is, when when the user management service logs in a user, the login is probably handled by the auth service. The logins are handled by the auth service. So what the auth service does is, it has a read-only connection to the user management DB. So it reads the user management DB, and it has its own auth DB, which is where it stores tokens on successful user login, and it deals with the auth DB for that. And that's, again, that's the whole purpose of the auth service and the auth DB. Moving on to the tweets and tweets and comment service, we'd have, and each of these would be interfaced with a queue. We'll have a queuing system. Using message queues is the best way to have them talk to the load balancer. And the tweet comment queue, tweet comment service would have a lookup of the cache of the most recent tweets and comments. That's something from the past 3 days, because those would be the ones that you would be accessing the most, that would have the highest reads. So that has to be cached. Let me zoom in so it's clearer. So those would be the ones that would be most accessed, most read. And if that's not in the cache, it pulls it up from the database and it shows that up. Yeah, so if something's published, it should directly go here. So I missed an arrow here. If it's adding a tweet or a comment or editing a tweet or a comment, that needs to go directly to the database because you're not going to the cache to build something. It's more of a post, so that has to go here. So I missed the arrow there. That's one thing that I missed. So let me just note that down. Review. Things I miss. Let me just do that and say first thing is read common service talking to the database base for posts reads adding new tweets and posts. So that way the cache is only taking care of things that have been accessed recently and not written to recently. And this just signifies that you would spawn new instances. Do we need this in the design? Probably not. Yeah, that's just wasting time in my opinion. This is understood, so I should probably just leave it to this much. Yeah. Another question that I have is, do we need to show duplicates of services? That's a little also. So creates or spins up. That's a good question. Then I moved on to the APIs. Granted, I did not write any GET APIs, which I should have. I think this was towards the end. I had the same issue last time as well. So I should get to the APIs. I should spend a little more time on the APIs. Yeah, I think what I did was I spent quite a lot of time. I did 45 minutes in total, out of which I said I just said maybe 10 of that was maybe 15 of that. Yeah, about 15 of that was math, or maybe more. I think 20 of it was math. I spent maybe 2 to 3 on API, and the rest, I guess 15-ish was on 15 to 18. Let's just say 17 to 18 on the diagram. Might be off. Let's just say 5 to understand. Probably. Yeah, but it was probably more like 12 to 13 on the diagram. No, it was about 15, I would say. Yeah, 2 to understand the problem. Yeah, a minute or 2 to understand the problem. That was about it. Yeah, so that's how I split this. So I should probably spend more time on the API next time. So that's, I think the next split should be well, I can just mark that here. The ideal split should be maybe 2 to 3 minutes on this, 10 minutes on this, and I should probably spend around 8 to 10 minutes. That's probably a bit much, but okay, we need that. I think 15 is good for this, or maybe 20 on the diagram. 20, 30, 40, yeah, that should be good. Yeah, so I get 10 from this. Where is my time going? 25, 30, 40. So this is about 20 minutes already. Is it? That's been 25 on the math. That's probably what I did. 22-ish on the math. I'm assuming this must have been 18, 17, 23. I'm thinking this is a rough estimate of how much I spent on that. Anyway, moving on to the questions. What were the questions we had last time? Let's see. Okay, SQL was NoSQL. So let's just do. So that's a good place. Okay, we don't need that. Okay. Okay. Hmm. It's not much of a difference. You could do row compression in SQL. no effect in text. But in car. Okay. That's that. We'll do another form. Ignore that. 51. We'll do 4 more minutes of this. And we'll switch over. Do we save or handle? Okay. Okay, we'll come back to this at a later point. That's not what I meant, but that's a good read. Okay. Okay. I'm assuming the answer for this is no. That's a long question, but oh, you should. It's good to know. It's a good. Okay. It's actually good. Oh, that's a good resource. Look into that again in the future. Yeah, Google search is nice. The Gemini does a good job. Now moving on to this. The first one we did. That's a good question. We didn't do that. We made assumptions for this. Actually, yeah, we covered pretty much all of these. But we did not talk about traffic distribution. Geographic distribution would be nice. Oh, bird. Yeah, we did do that. Says only tweet content per month, 3 requests. We did all of this. Good job. Compensatory right search APIs. We did not. Yeah, we didn't do this. We didn't cover that. So I think we missed. Level API. Yes, speed. Right search. Didn't cover SQL versus NoSQL. Capability issues. Service line on tweets. We didn't have enough time for that, I think. Tweets, intricacies of the database design. That's a lot to do in 45 minutes. Oh, I did not have enough time. Let's not get that.
Many of you guys asked me if I could do a system design video about how to design Twitter, and that's exactly what we're going to do today. So you take maybe tweets you need to in Twitter and read a lot, but they certainly do tweet as well as we. So when you think about the better solutions that you read, so to solve this, so and it's a pretty comfortable, pretty nice solution because we're doing a lot of computation.
Let's see. He goes.
When somebody is tweeting, but as soon as Bob enters his browser and accesses Twitter,
Oh, okay. Okay. What I didn't consider is, okay, I didn't consider that. I didn't consider drawing just a view in terms of what they would see. This person had a completely
he'll get a super fast response. So one more detail for this access diagram. At some point, the load balancer, a machine in between, has to know.
This is not really what I was looking for. This feels more flow-oriented than the actual design of the architecture of the system. Yeah, I was looking for the architecture. This is more flow. Okay, maybe he explains that in the video. Good, I will look into that. Let's stop there. The review. Okay, so 10 minutes on recap, 10 minutes on questions, 10 minutes looking the concepts up. This turned out to be 15, about 10. This was also about 5. Yeah. I'll be better next time. And yeah, the allocation of time here should be different. It should not be 2 to 3, 10 and 8 and 20. I think I need to spend more on the design and API. The math needs to definitely come down to 10. API needs to go up, yes, and the diagram also needs to go up, and it will be quicker on the diagram. That's it. Cool. Do the next one. Yeah, so this was the diagram.